In section 2.1, your text discussed the properties of limits. And what we've seen so far is that the derivatives have many similar properties. For example, the limit of the sum of two functions is the sum of the limits. We can take the limits individually and add them up. Well, we can do the same thing with the derivatives. Derivative of the sum of two functions, we can take the derivatives independently and add them up. Same thing, a constant multiple. The limit of a constant times f of x is the constant times the limit of f of x. We can take constant factors outside of the limit. Well, the same thing works for the derivatives. The derivative of a constant times a function is the constant times the derivative function. We can take constant factors outside of the derivatives. And the same thing works for differences. The limit of the difference of two functions of f of x minus g of x, well, we can take the limit of them independently and subtract. The same thing works for derivatives. The derivative of f of x minus g of x, well, take the derivatives of them independently and subtract. Now, the properties of limits have two more operations that they talk about. The limit of a product is the product of the limits. So the limit of the product of f and g, we'll take the limits separately and multiply them at the end. Does this work for derivatives? Well, I'm afraid not. But it's a common misconception that students have, so we should keep in mind some simple examples. Let's check this with the simple function f of x and g of x both be x. And then let's check each side of this expression. Well, if we look at the derivative with respect to x of f of x times g of x, that would be the derivative with respect to x of x times x, which would be the derivative with respect to x of x squared. Now, using the product or the power rule, we'd have this derivative would be 2x. So if f and g are both x, then the derivative of f times the derivative of f times g is 2x. All right, let's check the other side. The derivative with respect to x of f of x times the derivative with respect to x of g of x. All right, we're looking at, does the derivative of a product equal to the product of derivatives, like limits do? Well, let's check. The derivative of, using these same functions, the derivative of f of x, which would be the derivative of x, times the derivative of g of x, would also be the derivative of x. And the derivative of x, remember, x is x to the first, so that would be 1 times x to the 0. Same thing here, 1 times x to the 0. And notice these are both 1, so this derivative would be 1. Notice the derivative in general, the derivative of the product of two functions is not the product of the derivatives. Well, if that's the case, then we should ask ourselves, what is it? Well, we'll have to come back to that in a few minutes. The same thing, what about the limit of the quotient of two functions is the quotient of the limits. The limit of f divided by g of x is equal to the limit of f of x divided by the limit of g of x, provided this limit in the denominator is not 0. Does that work for derivatives? Does that work for derivatives? Well, applying the same functions, let's check out the derivative with respect to x of f of x divided by g of x. All right, well, if f and g are both x, this is the left-hand side, then this would be the derivative with respect to x of x over x, which would be the derivative with respect to x of 1 or x to the 0. And remember, the derivative of 1 is 0. On the other side, we'd have the derivative with respect to x of f of x. If I took these derivatives separately and divided, the derivative of f of x divided by the derivative of g of x is the derivative with respect to x of x divided by the derivative with respect to x of x again. And these derivatives are both 1. So we get 1 over 1, and that would be 1. Notice they're not the same. So the derivative of the quotient of two functions of f divided by g is not going to turn out to be the derivative of f divided by the derivative of g. Then the question is, what does it turn out to be? Well, we'll have to answer that question in an upcoming video.